Welcome everybody. Good afternoon to all of you. Thank you very much for attending this webinar about additive manufacturing. So my name is Tony and I represent Chemtron from Singapore. We are a complete 3D solutions provider. So we provide the solutions, we provide the services. We also do a lot of training programs for people who are interested in 3D printing. So without further ado, I'm going to go and start my presentation proper. So Chemtron, we were established in 1996, and we started out as a chemical company doing biochemicals, antibodies, clonings. We used to supply to all the hospitals and universities in Singapore. And our core business is actually trying to bring innovative technologies into our Southeast Asia region. And one of the best things that has happened to us is obviously additive manufacturing, and I will show you why in the next coming slides. So these are some of the brands that I represent. Some of them may be familiar to you, some of them will not be. So I will explain to you a little bit more about each of them later on in the presentation. So Chemtron, we actually went into 3D printing proper about 5 years ago, and we've gotten a lot of very impressive milestones, I would say. We were the first to install the Metal X Markforged 3D printer in Singapore and the whole of Southeast Asia. We were the first to do that. We also have 9 big wrap machines, which I'll explain to you later, in Singapore and Malaysia. We were the first to install the EnvisionTech WIDA HD CDLM jewelry printing in Singapore and the Ultra 3SP large format 3D printing system in Malaysia. We have hundreds of customers from different industries, from different industry segments all across Singapore, Malaysia, Indonesia, Bangladesh, Cambodia. And we've installed all these machines virtually in every single education and tertiary institute. So below are some of my famous customers that I've worked very closely with who have my systems and are using it currently for their production and organization use. So a little bit about me. When I started out this business, right, I had zero clue about 3D printing. I never knew what 3D printing was. I had no idea what it was all about. In fact, my background was an auditor. I was an accountant. I actually worked for Ernst & Young for 3 years, and I was doing auditing for companies. After my time there, I was looking for something different, and I like to talk, I like to present, and I joined the family business. And that's where I was given the task of expanding this up-and-coming technology called additive manufacturing in my country, right? So I started out from zero. And the reason why I keep mentioning this is because I want to tell customers and potential people over here that it's not a very difficult technology. For me, I have zero manufacturing background. I have no degree in engineering, but yet I still am able to learn and understand this technology easily. Which is, if I can do it, you guys can do it for sure. Now, for us in my company, what I do is I selectively pick very careful brands, brands that I believe will give a lot of potential, a lot of benefit to my customers. So whatever brands that I'm talking about are brands that I've studied properly and have a very strong impact in the market. It's not any kind of 3D printers. There are thousands of 3D printers in the market today, but the ones that I pick are the ones that I feel will give benefit to the people who have it. And that's why I picked out company names like Markforged, EnvisionTech, Big Wrap. These are one of the best and world-known, renowned brands around the world in terms of additive manufacturing. So let's move forward. So today I'm going to take you on an adventure. I'm going to take you into the whole thing about additive manufacturing from start to finish. Okay, so we're going to go through an adventure. We're going to understand what 3D printing is all about. So we're going to start off is, where are we today? Where are we with manufacturing? Where are we with the world right now, right? And then after that, I'm going to explain to you what is additive manufacturing and 3D printing. Where do we begin 3D printing? If somebody wants to start it today, where do we go? Where do we start, adopting this technology? And then after that, I'm going to talk to you more about 3D CAD modeling, 3D scanning, different technologies that are available in the market today, and where do we see ourselves in the future? Where do we see ourselves with 3D printing? So let's begin. So we all see this picture here. This is what we see in all manufacturing companies, the CNC machines, the milling machines, and all of that. This is a very common picture, common scenario in all of our, manufacturing companies, for example. Not to say that it's bad or anything, but it's just been there for a very, very long time. And this is what we are trying to move forward with. I'm not going to say that it replaces this technology. I'm going to say it's going to complement manufacturing, right? Additive manufacturing will never replace the traditional methods, but it is a step forward for new technologies and to leverage on both technologies to get the best for your customers. So let me give you a scenario, right? On the left is what we are very familiar with. We are familiar with the process, the manufacturing process. First, we have the design, right? We have the CAD modeling guys who design everything, and they come up with a digital file. And then after that, it goes into a prototyping stage. But during this stage, the manufacturing companies will need different kind of prototyping toolings to come up with a prototype, right? And after a few changes here and there, back and forth, with redesigning, we are then okay to go into production. So with that, you will need toolings, right, to get everything on board. So you need your fixtures, you need to fabricate the fixtures, you need the mold making, you need chem. All of these toolings are needed, and this takes a lot of time, a lot of process. And then after that, it goes into production. And that's when we talk about large-scale productions. You'll need the logistics, supply chains. And finally, you'll get your product in your hand, right? So the whole process involves raw materials, manufacturing, the shipping, as well as inventory. Now, the one on your right is where I want to bring you guys towards. Just imagine a scenario where you can design something, straight away print it overnight, and the next day you already have your design and you can actually use it. So this is where we are trying to bring additive manufacturing to. Not only prototyping, but end-use products and tools, right? And this is this is going to help customers speed up production time, speed up the process, speed up everything, so you can get your product design to the market faster, right? So recently, and we all know, and we are currently facing this, the coronavirus. Just overnight, we were not allowed to leave our homes. We all had to work from home. A lot of the manufacturing companies could not access their production plants. And what happened was that it affected supply chains, right? So people couldn't get the parts, couldn't get their equipment, needed, and there was a break in the supply chain. We have no parts, right? Because the whole supply chain has broken down, there is no more parts to be produced. There's no way we can get the parts. What do we do, right? And this is a scenario that could crumble a lot of companies who are reliant on this supply chains, right? And if they can't have the supply, they can't produce, everyone's on idle. So this is a very serious scenario that can happen. And it's already happened recently in the last 2-3 months. The other scenario is you keep so much inventory, you keep so much stock, and what if that whole production line or that machinery is obsolete and no one uses this because technology is moving in such a fast speed, right? If you keep so much stock of inventory and all of this is just, it's money basically lying there, and it's stuck and you cannot move this inventory, it's money tied there, you're going to lose a lot of cash flow, right? So this is another scenario that we don't want to end up with, where we want it to be like just in time, like the Japanese, like you get it and then straight away you can use it. But most of the time we end up with this kind of scenarios where it's overstock or oversupply, right? And we don't want that as well. So just giving you a little bit of a history tour. What revolution are we in right now? So we had the first revolution, which was water and steam, and that was in the 1700s, right? And then we progressed really fast. We went into the second revolution where electricity and mass production was working. That's in the 1800s. The third revolution, which is our era right now, it's the electronics and automation. So a lot of the things was automated, factory lines were produced. So we continue making a lot of mass production products. But this is still the third revolution, right? We have now entered the fourth revolution, right? And that is changing everything. And it's called digital manufacturing. This is the way it's going to change a lot of industries, a lot of sectors on how we run our business, on how we do things. And it's affecting every single industries across the board. For example, aviation, aerospace is getting affected, automotive, defense, energy, medical, consumer goods, anything and everything that you can think of. The industrial revolution is here, and that's the fourth industrial revolution. Smart manufacturing, right? That's the keyword. So how do we adopt, and how are we preparing ourselves for this fourth revolution, which is already here, so that we keep we are always ahead of the game in this? Because if we don't keep up with the way technology is moving, we will be left behind very quickly. So just a little bit about 3D printing in a whole and the impact that it has. So this was an article from Forbes, right? And from the Volas report, which is a very famous report on the 3D printing industry. In 2020, it's estimated to be about $15.8 billion for additive manufacturing products and services. And this amount is going to double or more than double by 2024. And that's in 4 years' time. So this industry is really, really growing really quickly, and it's going to be adopted very, very fast across our organizations. I mean, a lot of the schools, I mean, that's the first factor. If you see schools investing a lot of their money in this technology, you can understand that they are preparing the younger generation to take up this technology, and they take the skill sets to our existing companies and to implement this technology in their organization. So additive manufacturing is definitely going to grow exponentially in the next few years. And this is something that we need to be ready, right? So what is additive manufacturing and 3D printing? What is it all about? Now, to sum it up in a very simple nutshell, right? Basically, the first thing in the first diagram that you see in A is that you have a material block. This is very, very common and very familiar to those who are doing CNC and CNC manufacturing, right? It's called subtractive manufacturing, where you get a material, you put it there, and the machine cuts it into a lot of pieces to get your final object. And then you notice that there is a lot of wastage in this, right? This is what is called subtractive manufacturing. Is something that all of us know what it's about. Now, additive manufacturing, which in its word is adding, right, is you take the material, you put it into a 3D printer, for example, and it's adding material to the part that you want to print. So only parts that wanting to be that is needed to be printed, that is the part that comes out of it. So there is very little wastage. So that's how we differentiate additive manufacturing with subtractive. And this is the essence of 3D printing, adding materials to what you want printed. So how do we begin, right? So the first option, and this is a common option, is you have to do CAD modeling, right? So CAD modeling is basically all the softwares that are available. Some of you must have been already trained with these famous softwares. Some of them are free, and you can go and check them out online. It's basically creating a digital file, right? So you have a model or you have a 2D diagram, and from there, you create the file and you make your 3D object out of that. And the file that we are talking about today is called an STL file, right? It's something like a Photoshop file, like a PSD file or a PowerPoint file where you have PPT. Just imagine 3D printing is a STL file. That's the one that we want. So we get this file. That's one option, right? So now you have a digital file ready. The other option, a lot of my customers come to me and say, look, I don't have anyone who can do this. I don't have anyone who can model for me. What do I do, right? So the second option is 3D scanning. So 3D scanning is basically taking a scanner, and that scanner actually takes thousands of images of the object and it scans it to get your part, right? So I'm going to play you a video to show you what I mean. Take a look. So this is the scanning portion of it, right? So this is where you get a handheld scanner and you scan whatever object. And this is really interesting because sometimes we don't have the drawings anymore. They're really old parts and you want to do refabrication of this. This is where 3D scanning will come in. So the first option is you design your file and you get the digital file, or the second one is where you scan it and then you get your 3D file. Now we talk about, now we are at the stage where we already have our digital file, right? So that's the first step done. Now we want to recreate that file into the 3D printing object, right? So we need a 3D printer, for example, to do this. But in the market, right, there are so many 3D printing technologies as well as brands out there that provide different technologies for different applications, let's so to speak. So I have listed quite a number of famous technologies over here. We have FDM, the fused deposition modeling, direct light processing, DLP. We have the SLA systems, which uses laser, liquid additive manufacturing, which is a different, very new technology that is up and coming. We have the selective laser sinterings for those nylons, laser melting for metal parts as well with powder bed systems, electron beam melting as well, and direct metal laser sintering. So these are all different technologies that are there. There are much more also, but I couldn't fit everything in one slide. So this is just intro to you, that you can tap on the different technologies and each one has its pros and cons. So you need to understand what is your application and which application is suitable for you, right? Which machine is suitable for you, which technology is suitable for you. So today I'm going to run through a couple of very famous technologies, simple to adopt as well, and then explain to you a little bit more on it. So fused deposition modeling, right? That's the first one, FDM. So FDM is, how I like to explain this to my customers is, imagine you take a hot glue, the hot glue guns, you put a glue stick inside, and wherever the part is heated, right, that's where the glue comes out. So you are layering one layer by one layer by one layer where you want the glue to be. Same concept here, but instead of glue, we're putting in plastics. So the plastic goes into the machine and then it prints out layer by layer the object, and you get your 3D printed part, right? So this is FDM printing, fused deposition modeling. So something like this is how it prints. Layer by layer, it goes up. So what is the benefits of this technology? Number one, it's good for prototypes. It's good for models, right? It's easy to use. So even if you're someone who's just starting 3D printing today, you can plug in and you can start to print, no problem. Very simple and easy to use, I think. The disadvantages for this kind of technologies, the surface quality is not great. So if you're in the jewelry business or the dental business, this is something I will not recommend you to use, right? Also, another very common problem with this technology is warping and very bad accuracy sometimes. Warping is when, you know, imagine you have a hot object touching a cold object. It starts to shrink and warp, right? So this is a common problem that we have with this 3D printing, because the head is normally about 200 degrees and the bed is about 90 degrees. So when you hit it, there is some sort of warping that comes into play, which causes not a fully proper print, right? So what I'm going to share with you now is one of the FDM machines, which I believe is one of the best out there, I think, because I have tried a lot of FDM 3D printers, and the one that I really like and the one that I represent also because I believe in this product is the Markforged printers, right? So these printers are using the FDM technology. And the thing about these guys, right, is that they are the world's first company to actually print carbon fiber, Kevlar fiberglass, right? They are using these materials in the 3D printing object. So what does this mean? When I have, remember when I was telling you that 3D printing is just for prototypes and models? With this system, you don't have to print prototypes anymore. You're actually printing end-use parts, right? You're using carbon fiber, Kevlar fiberglass to make it so strong that it can be as strong as aluminum. And when you print it, you can actually use it for a functional part. And this is where it's being used in your jigs, your fixtures, your toolings, anything in your production line where you need to make something. Instead of fabricating with a CNC, you can now 3D print all of this overnight. And that's how it works. So let me show you a short video. There is no sound in this, so it's okay. What I mean. So this is where it's printing with the plastics and it's reinforced with carbon fiber, for example, or Kevlar. So this part that was 3D printed on the desktop, it's actually holding about 21 to 22,000 pounds, right? And that's about 10,000, 11,000 kgs, equivalent of lifting a car, a boat, a cement truck. So with this force, it actually, it finally broke at 11,000 kgs, about 11 tons of it. And that's the difference with the normal FDM machines that we see and these guys. So these guys are leveraging on the composites point of view. So some of the applications of Markforged 3D printed parts, basically everything and anywhere, right? Because if you can 3D printing something so strong, you can use it for your production toolings and fixtures, your end-use parts, your functional prototyping, drones, automotive and performance parts, as well as your prosthetics and orthotics. We have actually have customers in all of these industries, and they're all from Singapore also. And it's amazing how they are using this technology for their day-to-day production use. One example is that one of the hospitals needed to print a prosthetic, and we actually printed the whole cast for the leg. Drones and aerospace, we have a lot of drone companies who are using our materials and leveraging on Kevlar, for example, because it's good absorption of impact for their drones, right? So this is where 3D printing can come in and make an immediate impact, where you print it overnight, straight away use it the next day. Yeah. Now, what you saw earlier on was the FDM process, but one thing that a lot of people feel is that the parts that we 3D print nowadays, if you look around, it's actually very small, right? We only can print maybe up to 30 cm by 30 cm, and that's all we can go. But why must it stop there? That's why I chose, and I studied and I looked around and I found out about Big Wrap, right? So Big Wrap is a 1 meter by 1 meter 3D printer, right? So now you can print no longer scale parts, you can print huge parts, 1:1 scale for your use. And there are so many applications for this, especially in the signage industries, the props factories, the propeller industries, sand casting, molding, which I'll explain to you shortly. So take a look at this.
Every big idea starts with a question, a problem that needs to be solved, a passion to invent something new. We believe that through innovation and creativity, big ideas come to life. Introducing the Big Rep 1, a revolution in large-scale 3D printing. The One's award-winning design is rooted in uncompromising German engineering. Built with a capacity of over 1 cubic meter, the Big Rep 1 has the largest FDM build volume on the market. With the Big Rep 1, there's no need to scale down your original designs. Print objects quickly, reliably, and consistently. The open build design ensures that the user has the best possible view for monitoring quality from all angles. The 2 modular print heads allow for top flexibility when printing in 2 colors or with support materials. Their independent movement ensures a clean print result while changing between filaments. The print heads can be equipped with either 0.5, 1, or 2 millimeter nozzles. The 2 millimeter nozzle slashes build time. Whether you're producing a series of objects or designing a single product, large-scale prints now build faster. An integrated control unit and touch panel allow you to monitor print time, change the speed, or even adjust the temperature of the print bed, all while the print is in progress. Ideate, design, print. Here at Big Rep, we're making big ideas a reality for everyone. What is your next big idea?
So, for example, like one of my customers that is making propeller blades, they need to sand cast it. They make the propeller blade is a mold, and then after that they sand cast it to um, proceed in the fabrication process. So this is where the big rep can come in and help you with this, with large format printing. Some other examples, like I mentioned, the propeller on the bottom left corner, we have bicycles as well. They can print the bicycle frames. Even the tire is printed. The tire is also 3D printed with the big rep machine. Another one is also cement casting. So you can actually make the mold and then pour the cement inside to get the shape. So there are many endless ideas with large format 3D printing. So you're no longer limited with the size, right? So now we are going to move on to another technology called DLP, Direct Light Processing Systems. So let me show you this video to show you what DLP printing is about. So this is another technology that uses liquid, and then there's a light below, and that light shines on the platform. So wherever it needs to be printed, the light will harden that resin, and that's where you get your object, right? So this is how direct light processing system works. Now, what is the advantage of this? This is very important. For people who need the applications like dental and jewelry, you need very precise prints. This is where you need to use this technology. You cannot use FDM because you won't get that kind of quality from it. And the surface finishing is also very nice. So a lot of jewelry companies, for example, they get these machines and they use it for casting, investment casting. They get the jewelry mold itself and they cast it with gold or silver and stuff like that. For the dental side also, where they want to make the aligners, they want to make the denture bases, they want to make the crowns, the bridges, you can use that with direct light processing. The only problem is it's a little bit messy. With liquid resins, it gets a bit sticky and stuff, and it's also a little bit slower process. But if that's okay with you, this is fantastic for this application. So I'm going to give you some examples of what they are printed with 3D printing with a DLP process. You can do really fine prints, like a PCB board, for example. You can do a small production run for injection molding. You can also print very detailed models, features, sharp features that you need to get, right? So if you're in the toy industry, this is something that you will need to look at. Dental as well, dental clinics, dental labs, they're using this, they're taking this technology now to scan the patient's teeth with the scanner, and then after that, they 3D print the dental applications. And also, most importantly, especially in the jewelry industries, this is something that has been extremely famous in all of our Southeast Asian countries. They're taking up 3D printing for jewelry. So these are some of the examples that you can do with 3D printing of the DLP systems. Right? And now recently, with the COVID, they are printing the nasal swabs, right? Where they take the swabs and they test it in your nose to check whether you have COVID. So this is something that we are doing also for our customers. We are selling the machines and the whole system with the swabs as well. So 3D printing is very versatile and adaptive to its environment, right? If something happens, we just need to retool our machines and just put in another file and print it. It's very versatile. In fact, just to share with you, my team and I actually brought back all our 3D printers home when we were supposed to work from home, and we were 3D printing for our customers. That's because we could move the machines back to our houses, and it was still continued business for us. So this is a great way to adapt and diversify your business with 3D printing. Now I want to go into metal. So metal also is a very attractive technology that is 3D printing in metal, right? So a lot of the times complex metal parts cannot be CNC'd because they need multiple axis machines. But with 3D printing and the design of the 3D printing, you can actually print very sophisticated metal parts without having it to be machined, right? So things that couldn't have been done before, you can do it now. So the metal process that I'm going to talk about is from Markforged, and it's metal 3D printing called the Addictive process, where you first design your part, you 3D print it like how you did with the FDM machines earlier on, and then after that, it goes into a wash where the metal filaments, the solvent eats into the metal filaments, and then after that, it goes into a furnace to be burnt and heated, where it fuses together and you get your metal part. This is another very common 3D printing technology for metal would be the powder bed systems with the SLM technology, where a laser shoots into the metal powders and then it forms the 3D printed part. So there are many other technologies for metal, but this is the one that I feel is very good, because with powder bed systems, the main issue is that, let's say today I'm printing 17.4 steel and I want to change to titanium, for example. I have to vacuum out all this powder safely. And loose powder in the air is extremely dangerous to the user, right? But with this system, the Addictive process from Markforged, it doesn't need to use powder. It's already in the filament forms. So you can actually 3D print metal in your office or even your house, and it's no problem, right? The only thing that you need a workshop is the furnace and the washing stage that comes in the workshop. So you can actually 3D print metal, and with that, you can produce metal end-use parts. So some of them are using it for end-use parts, robotic grippers, and also metal prototypes. Our lead time for metal parts are, for example, 3 to 4 days. I get the digital file, I print it. After that, I go into the wash and then furnace it, and you get your metal part in 3 to 4 days. So it's an extremely fast system to explore, right? So this is all about metal printing. Currently, we can do 17.4 stainless steel, Inconel 625, copper. We can also do H13 tool steel, A2 tool steel, and D2 tool steel. So these are all the different materials that we can print currently right now. Lastly, this is a little bit interesting, right? So this is bioprinting. So bioprinting is something where a lot of the researchers will look into when they want to print out cells, human cells, skin cells, also like stem cells, right? These systems also require 3D printing. And to do this traditionally in the labs is very difficult, because you need to use the Petri dish, you need to lay it out, you need to understand the cell behaviors. So bioprinting is the future of medicine. So imagine in the next 5-10 years, if somebody has a kidney failure or a liver failure, they can actually come out and 3D print your organs, right? It's still in a very, very early stage, but this is where the technology is going. And the best thing about it is all the material comes from your own body, your own cells. So for example, if I'm going to do it on my body will not reject my own cells, right? So this is something that they're doing a lot of research on. So currently, like in this mice over here, they have actually 3D printed a cartilage of a ear, and they actually placed that cartilage onto the mice, and it started to grow on its own. So this is some of the examples that they're doing. 3D printing human soft tissues, stem cells. They are also 3D printing tumors to find cures for cancer, because tumors spread very fast. So what they've done is they printed the tumor in the machine itself, and they're testing it with different cancer treatments, and whichever that the cancer treatment works for the tumor, that's the place where it will not spread. So this is how they are working ways to use 3D printing, as well as the research of cancer treatment to make it faster and easier for the patients. there's a lot of talk of us colonizing Mars in the future, other planet, other planet occupation, for example. And in order for us to do this, we need to have systems like this in place so that we continuously able to regenerate ourselves, so as to speak. And this is being done with bioprinting. So this is also another form of additive manufacturing. So where do we see ourselves in additive manufacturing, and where are we heading towards, right? We are looking at a digital farm now, right? Now, what you see over here is about maybe 10, but in the whole facility, there are about 40 machines. 40 machines printing parts that are on demand. Only when you have someone who needs a replacement part, you can 3D print it. You don't have to keep stock. You don't have to use raw materials. You keep a lot of stock of raw materials. Only when things are needed, then you can print. And the best thing about it is all of this uses a cloud system. So for example, right now, I'm in my house. I can actually press print right now, and the machines will start printing in my office. And I don't even have to be there, right? So all of these systems are being taken care of by not many workers. Maybe one worker or two workers can run all of this facility easily. And this is where we are going, producing, manufacturing large scale at extremely fast pace without holding up much inventory and resources, right? This is where we're going to look at the production floor also, where it's going to be fully automated robotic wise. And with all of this robotics, you will need 3D printing to print the jigs, the fixtures, the toolings, and all of this. And this is where we're going to make extreme fast production, right, of any part, right? So there'll be lesser use of humans in that sense, but more automation and industry, what do you call it, IoTs, Internet of Things, to get parts produced much quicker and faster. So this is where the industry is heading towards, and we should be on board with this, adopt these technologies as fast